First things first, could you post the links into the chat after your talk, after the questions, so
yes.
that people are interested can easily grab them? You don't have to do it right now, but
Sure.
so the first question just dropped in. You want to read it out loud?
Good talk. So I just wanted to ask regarding the if conversion issue that you guys unearthed in Simplify CG. Did you guys take any action on that pass or figure out what needs to be done? Because for process which support masking, that may still be useful. So I'm interested in knowing how do you plan to tackle that?
So there's we looked into this. The issue still exists in LLVM 9. I haven't looked into 10, but the interesting problem is that actually there are expectations in a test suite that if conversion always happens. So there's actually the fix itself to the code for the Simplify CFG might be relatively contained, but it has implications on the entire system, and that basically needs kind of a community take-up to see how to address this in the best way. But we have a patch. Actually, it's I'll post that link as well on the chat. We have an earlier patch published on the website of ours, but we haven't taken it further at the time being.
Okay, thank you.
Maybe I shamelessly plug into that question. When you ran these results, did you enable PGO, like profile guided optimizations?
No, that was systematically what we wanted to do is use just the standard decisions of the compiler. So no profile.
But to be fair, profile information is part of the standard decisions of the compiler, yes, if you provide it. Because like the thing is, you said, oh, this is a kind of the tight loop that is hot or whatever, and then something happens. And as IL is going to ask in a second, there's like heuristics are not perfect, right? You have trade-offs between different things, and the one way to fix like a problem like this is to provide the compiler with more information, because there is no right choice in doing something. Yes. It's good and bad at the same time. It now depends on the situation. And I think to make really sense here, as long as at least it's not always good or always bad, profile information should be taken into account for these cases.
Yes. So this actually is a step which has to be taken in the sense that the infrastructure as it was set up originally was for a straight single pass compilation. Indeed, in order to handle the PGO loop, you have basically to adapt the framework, but essentially, per se, the approach works with PGO as well. It's just that you have to run your program twice and recompile the second time with PGO with the profile information provided to the compiler. The thing is, it essentially doubles the size of your data sets that you collect, right? Because you want to see this, but to be true, we just haven't explored PGO. It was more about using a systematic square method to see, is there a delta that can be exploited?
Perfect. Maybe that leads into Ayal's next question.
Hi, can you hear me?
Yes, perfectly.
Hi.
Ayal.
Thanks, Zbigniew. It's been a long time. Yeah. So a quick question. So you mentioned like that loop rerolling may be advantageous for ARM and other benchmarks, but it could be that a pass is helpful for some loops or some constructs, and then for others not so much. And if you only apply it in an all or nothing context, you might actually get the benefit together with the degradations. And it may be worthwhile to try this technique in a finer granularity where you can actually check if a pass is actually providing some harm and some help.
Well, here the granularity is that of successive transformations. So if I go back a little bit in the slides, so we took a systematic brute force approach, which is that any pass that is a transformation pass is a cutoff at which we check the effect of the transformation. Actually, of all preceding transformation passes up to that one. So for small benchmarks, this method pinpoints issues that are linked to effects of successive transformations. Now, if you add the degree of variability, which is having multiple loops, for example, in between which you have interactions in terms of performance, code size, etc., well, that's a separate research activity that we had actually on optimizing applications per module, where you try to find the best for each of the individual modules of a large app, and check whether the assembly of the best per application choices, actually transformation sequences, is as effective as the sum of the gains.
Understood.
I mean, there is a huge potential behind it's really has to be tailored to the needs of a specific, I would say, customer, in the sense of a group having a class of applications, for example, a class of targets, and let's see if in that case what can be achieved, what is actually hidden in the shadows and can be exploited for that in that specific context.
Right. So yes, I agree that if you're looking at small kernels, then maybe an activation of a pass is somewhat atomic. But as you may look at larger code bases, then you may applying a single pass may actually have a combined effect that may hide some of the potential.
Yes, and here we've seen already that there are effects of, for example, transformation triggering thresholds that show interesting artifacts, and those thresholds are actually not target dependent, which is a bit of a problem, because they have to may have to be tailored to at least classes of targets.
Understood.
Jeremy, you had a question?
Yes. Hi, Zbigniew.
Hi, Jeremy.
Thank you for the talk. The question I have is the benchmarks you're using, the Dividiti benchmarks, are very, very small. We're talking tens of lines of codes and one or two functions. Do you think there are issues about applying the learning you get from such optimizing such tiny fragments of code to huge HPC kernels?
Well, there will be. So let's put it this way: the method on small benchmarks helps isolating precise, specific shortcomings. Optimizing applications which have multiple points of points where a transformation can be applied will clearly result in some noise and a plus-minus effect. But we can approach this by separating the application into smaller entities. So even phases of computation which have a specific loop nest, for example, or maybe a larger unit, but somewhere close to a serious loop nest, and optimize each of them, or actually analyze compiler behavior or optimizer behavior on each of those groups separately, or each of those modules. And then obviously there will be no perfect composition of gains that you observe, but they do add up to a certain extent. I mean, if you're not counterproductive, if you don't have actually a crosstalk between two loop nests, for example, if you process them separately and you assemble the optimal form of each of them, it should, well, but it's not guaranteed, obviously, it should bring a significant benefit.
Okay, so if I understand you correctly, you're very much saying, sort of in the sort of whole milepost magic approach of using the correct optimizations for each individual function so that you can learn what works and apply accordingly, which is a strategy that is known to work.
So this is the strategy that can be exploited directly with the approach. Obviously, if you have interactions which are, say, highly nonlinear, put it that way, we may observe some interesting artifacts. But then again, this approach can help isolating those cases where you have a crosstalk between two parts of your large application, and depending on how you transform them, they will behave differently put together.
Okay, thank you very much.
You're welcome.
Okay, the last question, Thomas, you want to ask the last question and for the break? You seem to be unmuted, but I cannot hear you. I'm going to ask the question you put in the chat. So he asked, what is the number of tests that you generate here?
So per benchmark, we generate 60-something tests. That's the number of transformation passes in opt that form the -03 chain. Let's put it that way. That means that you get 60-something instances of your benchmark times all your benchmarks. It doesn't explode. It's linear in terms of say in the number of passes in the compiler.
Okay, sounds good.